This lesson is on single variable data. We're going to be talking about collecting, representing, and interpreting data. Our learning goal is that I can solve problems involving percentages with applications to data and finance. I can analyze data involving a single variable. There are two kinds of data we're going to be talking about, continuous and discrete. The easiest way to remember this is discrete is something that you can actually count individually, and you can never have half or a part of one. There's some language that goes along with this as well to be grammatically correct. We talk about less or fewer, and the word we use depends on whether we're talking about continuous or discrete data. We use fewer if it's something we can actually count, or less if it's continuous data. So let's look at how this works out. When I drive, I try to use less gas. A kindergarten class has fewer students than in grade 8. To cut calories, I use less butter on my toast. My new TV takes up less space. My mom has fewer friends on Facebook than me. So you can see that we used fewer whenever it was something that we could very specifically count. And you never had you never have a partial student, you never have half a student, you never have half a friend on Facebook. So we use the concept of less and fewer when we're talking about discrete and continuous graphs. As we said, data comes in two styles. Continuous, where we're talking about something less, so things like time, length, volume, cost, those are all continuous types of data. Continuous data can include integer and decimal values. When we're talking about discrete data, we're talking about fewer, and examples there are things like number of people, number of books, the number of socks, so things that you can actually count that only include whole numbers, no decimals. Let's try and do some matching here. Start just first of all with the less and fewer. If we're talking about jam or jelly beans, which one do we use less and which one do we use fewer? If we're talking about the jam, do we choose less or fewer, and is it discrete or continuous type of data? So with the jam, we can put less jam on our toast. That makes it continuous, right? We wouldn't say you're putting fewer jam on your toast, it's less jam on your toast. Conversely, you can eat fewer jelly beans. That makes it discrete because you can count specifically the number of jelly beans that you're working with, or the number of jelly beans that you're eating. So today, we're going to talk about representing data. We're going to talk about pictographs, bar graphs, circle graphs or pie charts, histograms, and we might get to mean, median, and mode, but I think that might be for a different lesson. Then next week, we're going to talk about box plots. A pictograph refers to the representation of data by making use of images related to the data. It's one of the easiest ways to represent statistical data. You might have used this approach if you did an information graphic when you were in grade 8. That's a common assignment. So an example of a pictograph would be this, where you've got the various blood types down the side, and you're using symbols here rather than sort of a traditional bar chart. And it's important to note that down here there's a legend which tells you that each blood drop represents 5 people. Bar graphs are one of the most common graphs. We use bar graphs to compare data among categories. The longer the bar, the greater its value. So it's not so different from a pictograph, because the longer the bar we got here, that indicated more value. So this is the longest one. That's the most people have the blood type of O. Bar graphs make it easy to compare sets of data between different groups at a glance. So it's very easy to see where if you've got the homeowners here, they're grouped by years. You can see here we've got it 68%, and here we're at about 50%, or 50.1%. So it's very, very easy to compare because it's visually you can see that the bars are getting taller as you go along. The graph represents categories on one axis and a discrete value on the other. The goal is to show the relationship between the two axes. So on the horizontal axis here, so on the x-axis along here, those are where the data is grouped, right? It's grouped by year, and then we've got discrete values going up on the side. So we've got percentages, and you can end up at any point along there on that y-axis. And finally, a bar chart also shows changes, big changes in data over time. So in this case, we don't have a really dramatic change, but it's still very clear to see how much change has happened over time. And you can see that there's kind of a continuous trend pretty much of the home ownership rates slowly getting higher in a percentage. This is another example of a bar graph. This time it's horizontal. It works well when you have a lot of categories, so you've got a long list. This one's a little bit out of date now, but because none of the major leaders are still in their roles. We've replaced all these guys. Anyway, all these guys have been replaced. But again, it's very easy to see. You've got a pretty close race here between those two guys at the moment. The NDP is putting in a pretty strong showing, and then these other guys are significantly further behind. So it gives you a really good visual feel for how each of the parties compares in their popularity. You can also do combined bar graphs. So in this case, it's putting two categories along the horizontal axis and kind of grouping them logically together. So what they're showing you here is that this is the area of the continent, and this is the number of people in the continent. Combined together gives you an indication of density. So here we've got a very large space, but it's got a lot of people packed into it. If we compare that to this one, which is Antarctica, it's pretty big. But man, there's nobody living here, right? So you've got a much lower density there. And then even Africa, again, pretty large landmass, but considerably fewer people. Still a lot of people, more than in North America, about double, I guess, what we have in North America. But there's a much bigger gap there than there is in Asia. Now let's get a little more practical here. We've got the days of the week across the bottom, and we've got kilograms of rice going up the left-hand side. The first question asks us to find the day when the consumption of rice is at its maximum. So look at the graph, and very quickly you're going to see that Monday and Wednesday look like they're pretty much the same. So those are the days when the consumption is the highest. Then it asks us to find the day when the consumption of the rice is at its minimum. So we're looking for the smallest values. And again, pretty easy to see with a bar graph as to which one is smallest. So Thursday and Saturday are when it's smallest. Now, what was the consumption of rice on Monday? Well, again, pretty easy to see because it's right there. Looks like we're at 90, and that's times 1,000. So we can say that it was 90,000 kilograms were consumed then. And then how much more rice is consumed on Wednesday than Thursday? So since those two are together, it's asking us what's the difference here between here and here. So if this is 90,000 and this one looks like I guess that's 40,000. So the difference is 50,000. Histograms show a distribution of data over a range of values. The horizontal axis, so remember the horizontal axis is the one that goes this way, that's horizontal, shows a distribution of data over a range of values. So what it's showing us here is that every tree that's between 100 and 150 centimeters in height is included in that group. So it's a way of grouping things that have continuous data. The horizontal axis is showing height in centimeters, and the vertical axis shows us the number of trees that fit into each interval. So it's telling us that the number of trees here that fit between the 0 and 150 centimeters looks like that comes into maybe there's 4 of those. And the number that are 150 to 200 centimeters, that's this group here, looks like there's about 30 of those, and so on. Circle graphs, or pie charts, are a visual representation of data made by dividing a circle into sectors that each represents part of a whole. Usually the amounts in each sector are represented in percentage so that all of the amounts total 100. So in the example that we've got here, they've given us a circle graph of 50 students, and they asked them, what is your favorite ride? And so then they tabulated that, and there's 12% like roller coasters, 8% like the Ferris wheel, 32% like the scrambler, and 48% like the bumper cars. In total, they add up to 100%. So if you're trying to get a sense of which ones are more popular, it's really easy to see that clearly bumper cars are much, much more popular than the Ferris wheel. It's even fairly easy to see that the Ferris wheel is less popular than the roller coaster. This is a very advanced type of graph. We're not going to dig into this, and you don't need to know this for grade 9 math, but it's just an interesting way of representing incredibly complex data with more dimensions than what we see in a simple pie chart. It's called the Coxcomb chart. Go back to a regular pie chart, though, and see how useful it can be. We've got a survey here, the results, where they asked people what their favorite ice cream was, and there were 200 ice creams sold, so they asked 270 people, or I guess they just probably measured their sales to see what they'd sold. It says, what percentage of ice creams were strawberry ice cream? The information they're showing is, they show us in degrees. Well, that's not really what we want to know. That's important when you're trying to construct the graph. But we're looking at strawberry, so that's this section right here, right? That's strawberry. It's not exactly clear how much that is, but you can do a pretty reasonable estimate. You think about it, if you split it this way, you broke that circle into 4 even blocks, then each one of those would be 1/4. 1/4 is equal to 25%. And what we're seeing for the strawberry is it's a little bit less than 1/4. It doesn't make it all the way out there, right? So it's just a little bit less than 1/4. Well, if 1/4 is 25%, then it's a reasonable estimate to say that what we've got there is about 20% for the strawberry. The second question says, how many ice creams does that represent? So they're saying if you've got 20% of the ice cream, how many does that mean if you sold 270? Well, if you remember from earlier days, if we take that percentage, 20%, convert it to a decimal, 0.20, and we want to know what's 20% of 270. 20%, 0.20 times 270 is equal to 54. So therefore, there were 54 ice creams sold that were strawberry. So it's important to choose the right type of graph when you're graphing data. Here's an example. 3 students surveyed grade 8 students in their school. They asked, how many times did you use a vending machine last week? And they gave them categories, 0 times, 1 to 3 times, 4 to 9 times, or 10 times. Amrit displayed the results on a circle graph, Fred used a bar graph, and Stella used a pictograph. What are the strengths and limitations of each graph, and which graph is most appropriate, and then justify your answer. So we'll get into the analysis here, but you can see you've got pie graph, fairly easy to see there's what each of the categories are representing there. The bar graph, it's maybe a little easier to see, which one is tallest. And the pictograph is pretty easy to see, but maybe it's a little hard to interpret when you've got all those icons there. So let's see if we dig a little bit deeper into each one of them. So when we choose the most appropriate graph, a circle graph has some strengths. It shows parts of a whole. So if you're looking at how many out of something else, then a circle graph might be your best bet. Each response is shown as a percentage of the number of students who responded, and the sizes of the sectors can be used to compare responses. Unfortunately, there's some downsides there, some limitations. The graph does not show the number of students who chose each response. It gives you the proportion or the percentage, but it doesn't show you exactly how many. The total number of students can't be calculated easily. It's difficult to draw accurately unless you've got a protractor, and that can certainly be time-consuming. With the bar graph, the heights of the bars can be used to compare responses. The scale of the vertical axis, remember the vertical axis is the one that's going up here, the y-axis, is 1 grid square represents 4 students. The scale can be used to calculate the total number of students who responded, and they're quite easy to draw. The limitations, or the downside, the bad things about them, are some people may find this graph difficult to read accurately. In this case, none of the bars end up on a specific grid line, so you're constantly interpolating which value it actually is. Some people the graph does not show the percent of the students who chose each response, so it's showing you the exact numbers, but it doesn't give you a percentage breakdown. And then when we look at the pictograph, the lengths of the rows of symbols give an immediate comparison of responses, so it's fairly easy to quickly tune into the fact that, well, the 1 to 3 seems to be the biggest category. It's visually appealing because it's got some engaging graphics on it. And the key is that one symbol equals 2 students. The key can be used to calculate the total number of students who responded. 1/2 of a symbol represents 1 student, so a full symbol is 2. There are some limitations, of course, however. There are a lot of symbols on the graph, and particularly when you look at that really long one, it's 11.5 symbols. That's a lot to actually calculate. You really have to sit down and sort of count them one at a time. It's not something you just look at and quickly identify. It may be difficult to draw. So many vending machines, if you're drawing those by hand, that's going to be very hard to draw all those symbols exactly the same. And the graph doesn't show the percentage of students who chose each response. So each graph has its pluses and minuses. So which one is the most appropriate graph? And the reality is the answer depends on what the students want to display. What are you trying to communicate with that graph? If their goal was to display the fraction or percentage of students who did not use a vending machine, then the circle graph is the most appropriate. The percentage or fraction of those who did not use it is easily seen and compared to the total. So let's go back and look at that. So you can see this is the category here that is 0 times. So it's very easy to see it's a pretty substantial size wedge in the pie chart. However, if they want to display the number of students who did not use a vending machine, then the bar or pictograph is more appropriate. The height of the bar or number of pictures can be easily used to find the total number of students. So you want to choose the type of graph depending on the information that you want to convey to the person who's looking at it. Now it's your turn. Try the homework.